This is for assistance with 3.7.5, which was a practice section on modeling a pumpkin launch. So what I'm going to do is I'm going to demonstrate how to go through it with the melon. So then you guys can either choose the pumpkin or tomato. So don't choose the melon launch because that's the one that I'm going to do. So what you're doing is launching with a catapult, some different veggies and or fruits. And we're going to take a melon and we're going to launch it a total distance of 40 feet. So laying that out on our XY coordinate system, with X being feet along the ground and our Y being feet in the air, what it says is the maximum distance is 40 feet. So I know that the melon will land out here at 40 feet. But it's kind of important to know that that is the point 40, 0. It's an x-intercept, obviously, of the graph. And we started at a distance of 0 feet. And then it's really important that it says, sorry about that.
Call Joan at 2140, please. Kim Davidson, call Joan at 2140.
So it's important that it says on here that the maximum height is reached, and its maximum height is 12 feet. So the maximum is always reached right in the middle of the interval. So it gets launched, it goes up, and it follows this parabolic path where the highest it gets on here is 12 feet. So what that means is the coordinates up here of the vertex, or of the maximum, would be 20 feet into the launch. It maxes out at 12 feet. So there's a visual of what's happening with the melon. Well, the next question says, so it says you're supposed to draw a graph of that, and I've got that going. And then it says, what are the coordinates of the x-intercepts and the vertex? So we've got all that going right here. And it says for number 4, it says using your coordinates from question 3, write an equation of the parabola of the form. So let's write down that format. So this would be answering question number 4. So write an equation for the parabola in the form of y equals some constant times x minus, and they say r sub 1, which is really an x-intercept, and x minus r sub 2. So keep in mind, since your x-intercepts are 40 and 0, and those are what causes the y's to be 0, what that means is we know that this is a times x minus 0 and x minus 40, because the solutions to this would be 0 and 40 would give us our x-intercepts, or y values of 0. So I'm starting off with that, and what I've got to figure out is, well, what is this a value actually? I know it's got to be negative because this parabola is opening down. So we know we're going to get a negative a, but the question becomes, well, what is it? So what I'm going to do here is show you how to find that missing a in the parabola. I'm trying to extend the page here. If I can do that a little bit. Move this up and do a page extension. Sorry. Okay, there we go. So the next thing up is to figure out, well, what is a? So I'm going to clean this up a little bit before I do that. Obviously, x minus 0 is just x. So I have ax times x minus 40. And this is modeling the path, or the points everywhere along this parabola work in this equation. Well, keep in mind, I already know that 40 will spit out a 0, and 0 will spit out a 0. It's that vertex that's going to help me figure out, well, what is a? Because I know that the maximum height of 12 is reached when x is 20. So I'm going to use that to help me figure out that missing coefficient right here. So really what I've got is 12 has to equal 20a times negative 20. Or equivalently, 12 has to equal negative 400a. And when I divide 12 by negative 400, I get a negative 0.03 for my A value. So that's the key right there, is using the coordinates of the vertex, the 12 and the 20, to figure out what that missing A value is. So now when I write my equation, okay, back up here, draw a little arrow down here, I know the equation for that parabolic path is y is equal to A, which I just found, negative 0.03, x times x minus 40. Alright, so you'll notice that this will give me x-intercepts of 40 and 0, and my vertex would be at 20, 12. So what was the next part of the question here? The next part of the question said, so I did question 4. Question 5 says to put the parabola in vertex form. And they tell you what vertex form is. Vertex form of a parabola that has a vertex, and I'm just going to put the general form, at h comma k. In our case, h would be considered 20 because our vertex occurs 20 over, right in the middle, and they said the melon was a maximum height of 12. So kind of keep in mind that when I write this out, the h for us is 20 and the k is 12. In vertex form, looks like y is equal to a times x minus h squared plus k. So for our model, we knew that our a was negative 0.03 because I just found it. My vertex is at 20, so it'd be x minus 20 squared, and my k is 12. So that would be in what we call vertex form. Its vertex is at 20, 12. And that's why they call it vertex form, because it's so easy to pluck your vertex off of it. Now, question number 6 actually said, are your expressions for number 4 and number 5 equivalent? Well, loosely speaking, they have to be because they're both representing the path of the melon. So they're equivalent expressions, they're just in different forms. It's kind of like when you have a line and you write, well, y minus 1 is equal to 2 times x minus 3, and we call that point slope form. But another form of that would be if I distribute the 2 in, and then I add the 1 to both sides. This is slope-intercept form, and this is point-slope form, but they're equivalent, and they both represent the same line. Well, similarly, this equation for the path of the melon is identical to this one. They're both representing the same path. Now, technically, I don't know that you can just say, well, logically, they have to be. I think what they want you to do is actually do the math on that one. So they want you to, I'm not going to finish that off because it's just some manipulation, but they want you to distribute this in and distribute that in and get an expression. And then take your second one right here, your second form, and prove that it equals the same expression. And if you're wondering, well, how would I do that? You'd have to FOIL this, distribute the 0.03 in, and then add 12 on. And if you do all that arithmetic and algebra correctly, you'll find that they are indeed equal. So those are the main questions of that. I hope that helps. If you have any further questions, let me know. I can't bring up the interactive software on here, so that you'll have to do on your own. All right, have a good one.